Hello students, today we see some more problems on nature of light, that is mainly wave properties. See the first one. So a Vivid Bharati station of All India Radio. So actually just like we have now different channels, already we know the radio is also having different channels. Same the first channel All India Radio. ఓకే మనకి జనరల్ ఇఫ్ యూ సీ ద దూరదర్శన్ నేషనల్ లెవెల్ ఛానల్స్ స్టేట్ లెవెల్ ఛానల్స్ ఆర్ దే సేమ్ రేడియో స్టేషన్స్ కూడా ఆల్ ఇండియా రేడియో స్టేషన్స్ హైదరాబాద్ స్టేషన్స్ అట్లా ఉంటాయి ఓకే సో ఆల్ ఇండియా రేడియో స్టేషన్ of Delhi. Okay, so broadcast a frequency of 1.368 kilohertz. Okay, it broadcast, it telecasts the different programs at 1.368 kilohertz frequency దగ్గర programs వస్తాయి. So just you have to find the wavelength of that light. Simply the frequency is given, you have to find the wavelength. So what the information is given in the problem? Frequency new is 1.368 into, so always we have to do the problem in terms of heads only, not in the kilohertz. 10 power 3 heads. We have to find the wavelength lambda. So we know the relation mu is equal to c by lambda. We have to find the lambda is equal to c by nu. See, we can take any value. Okay. See, we are taking in meters 3.0 into 10 power 8 meters per second by 1.368 into 10 to the power of 3 heads. Heads means we can write the second inverse. So on that overall calculation will become it gives approximately 219.3 is given. Okay, 219.3 meters. So actually here we get an approximate 2.9. Okay, 2.192 into 10 to the power of become 5. Okay, so in terms of meters. Okay, let's see the next problem. So the wavelength range, so actually in the last problem, okay, so the wavelength range of visible spectrum extends from, so violet color, we know that, so that is given 400 nanometer frequency with GR, that is 2 red color. So red is given 750 nanometers. So this problem is express these wavelengths. Express these wavelengths in frequencies. So nothing but in heads. So it's also very simple. So here VIBGR, we know the VIBGR range, visible light means nothing but VIBGR, violet to red. Okay, so the violet, so starting violet region, most energetic, least energetic red, so means its range is from violet to red color. So violet color having wavelength 400 nanometer. Red color is having wavelength 750 nanometer. Just we have to express. We have to express this frequency, this wavelengths into frequencies. So first for violet, we do it first for violet color. So what is lambda is given 400 nanometers. Nanometers. So we never do the calculation in nanometers. Convert it into meters or centimeters. Have to find the frequency. So nu is equal to C by lambda. What is the C? Meters kabatti meters per తీసుకున్నాం. In meters it is 10 to 8 meters per second. Okay. Meters per second. This is how much? So this is in meters. So meters get cancelled. Finally, we will get only the second inverse. Okay. So then approximately we will get 7.5. 14. Second inverse, nothing but heads, both are equal. Next, we do the same calculation for red color. Okay, means this is the frequency of a red color. Sorry, we calculate it for violet. So the frequency of a violet color is 7.5 into 10 power 14 second inverse. Next, do it for red color. Calculation for red color. Say mu is equal to the formula is mu is equal to C by lambda. So for red color, what is the lambda is given 750. Meters, we have to find the frequency. So therefore mu is equal to C, it's meters per second. So finally we will get 14. Finally we will become its frequency in terms of a second inverse. Hence, so this is a frequency of a red color. Okay, just you can write the last sentence that the visible region extends from violet to red, writing with their frequency values. Okay. Let's see. So calculate wave number frequency of LO radiation. So we have to calculate the wave number and frequency of yellow color radiation having 5800 angstrom. So means exactly last problem. So last problem మనం రెడ్ కలర్ కి వైలెట్ కలర్ కి వేవ్ లెంత్ ఇస్తే ఫ్రీక్వెన్సీ ఫైండ్ అవుట్ చేసినాం. సేమ్ అదే మోడల్ ఇక్కడ ఫర్ ఎల్లో కలర్ కి లాంబ్డా ఈస్ గివెన్. సో అప్పుడు angstrom it is given in angstroms. We have to find. సో దిస్ వేవ్ లెంత్ ని మనం ఫ్రీక్వెన్సీలోకి అండ్ వేవ్ నెంబర్ లోకి కన్వర్ట్ చేయాలి. ఓకే, so first see, so calculation of a wave number. So what is the wave number? Below the formula, nu bar is equal to 1 by lambda. So exactly what is the lambda? 58 angstroms. Therefore nu bar is equal to 1 by, convert it into centimeters or meters. Okay, 1 angstrom is equal to minus 8 centimeters. So this wave number calculation manaki, so calculation part may be difficult. So it's become minus 6. So the finally we will get so approximately 1.724. And to the power of 4 centimeter inverse. Next we calculate the frequency. Okay. So calculation of frequency of yellow color radiation. So again it is given, wavelength is given, we have to find the frequency. What is the relation? Frequency nu is equal to c by lambda. C, so c we are taking 10 power 8 meters per second. You can take centimeters per second by taking 10 power 10 also, it is our choice. So what is the lambda? Lambda 5800 into, so angstroms we should convert it into meters. Because centimeter convert చేస్తాం, just for different ఉండాలి మనం meters లో convert చేస్తున్నాం. That is a minus 10 meters. Okay, so get cancel. So here becomes a 3 by 4 minus 8. So here we get approximately 0.05 power 16 if you made it 14. It is hedges are nothing but the second inverse, both are equal. See one more. So calculate the wavelength. Wavelength of an ultraviolet wave if its frequency is 12 into 10 power 16 cycles per second. We know that cycles per second is also unit of a frequency, and C is good separately given in this problem 3 into 10 power 8 meters per second. So it is also given for ultraviolet radiation, UV radiation. We have to find its frequency, whereas its frequency is given, we have to find wavelength. So the same model, so basic formulas, we have to find wavelength. If a frequency is given 12 into 10 power 16, see cycles per second, second inverse, heads all are equal. Okay, just we are writing per second. Next, what is the frequency wavelength? We have to find wavelength. Find. So C is also given 3 into meters per second. So we have to find the wavelength. That is mu is equal to C by lambda 8 meters per second. Sorry, we have to find lambda. So lambda is equal to C by nu. Now what is the new value? That is 10 power 16. That is 1 by 4. We can say 0.25 minus 8. That is 2.5 into 10 to the power of minus 9. So meters. Okay. This is the land of ultraviolet light having this much of frequency. Okay.